All right, so this is the homework assignment, and the goal is for you to try a lot of this on your own. But I am going to walk through the problems as well, because although this is an interesting set of problems here, it might need a little bit of prompting for you. There are some hints, or at least one hint that's embedded within the document here, I guess the first one right up here. So if you click on that, you'll get a little video hint. It won't necessarily walk you through the answers, but you'll get a little video hint here. But otherwise, if you've given this an attempt and you're getting kind of stuck, I'm going to start walking through maybe how we would do this set of problems. All right, so below are the prices for a medium 2-topping pizza and a medium 4-topping pizza at Domino's. So the medium 12-inch hand-tossed pizza for $13.97. Notice it has 2 toppings on it, pepperoni and green peppers. And then the other medium is $16.95, and it has bacon, chicken, mushrooms, and green peppers. So one has 2 toppings and the other one has 4 toppings. So how much do you think Domino's is charging for each pizza? Sorry, how much do you think Domino's is charging for each topping? We already know how much they're charging for the pizza. How much for each topping? Well, notice that increased toppings does increase the price. So, what would that base cheese pizza be? And then how much are they adding on per topping? Well, if we think about this, maybe we can break it down like this. We know that the first pizza has 2 toppings. So if we think of this kind of like a point that we're graphing, the first pizza has 2 toppings and its price is $13.97. All right. And then the second pizza has 4 toppings and is $16.95. So we talked about the slope or rate of change and how to calculate a rate of change. And really, that's what we have for each topping here. As you add 1 topping, then the price increases by a certain amount. So the question is, how much is it increasing per topping? So let's think about that as a rate of change or a slope. So each one of these is going to have an x value. So let's call this x1, y1. Let's call this x2, y2. And like we talked about in our notes review, if we subtract the y values, so 1695 minus 1397, that's the change in y. And then the change in x would be just 4 minus 2. So if we subtract those 2 y values, we get $2.98. And if we subtract the 2 x values, the toppings, we get 4 minus 2 is 2. And then dividing those, we get $1.49 or 1.49. That is the slope. That's our rate of change. And that's going to be the amount per topping. So $1.49 per topping. So how much would you expect to pay for a plain cheese pizza? Well, we know 2 toppings gets us $13.97. So let's think about, all right, what would 0 toppings be then? So if we take $13.97 and we take away the 2 toppings, so if we take away 2 toppings at $1.49 per topping to get us down to 0 toppings, 13.97 minus 2 times 1.49 gets us to $10.99. And that would be our cheese pizza. In other words, 0 toppings other than the cheese. I guess that counts as a topping, but usually you're given that topping. Because what is a pizza without cheese? And that also tells us something about our eventual graph. That's really our y-intercept. So because for 0 toppings, our base price is $10.99. So write the equation you could use to determine the price of the medium pizza for the given number of toppings. Well, now we know in our y equals mx plus b equation, we know the slope and we know the y-intercept. So now we can write that equation for the medium pizza as 1.49x plus our y-intercept of 10.99. Remember, this is price per topping, and this is original plain cheese price. So our y-intercept and our slope actually mean something in the context of this equation. Graph your equation on Desmos and sort of screenshot of your graph at the end of this assignment. All right, let's see if we can kick over to Desmos here and use the graphing calculator part of Desmos, and we can type in y equals 1.49. Let's see if I can get that decimal. 1.49 x plus 10.99. And if you ever need to change your scale a little bit, you can just squeeze the y-axis. I'm taking two fingers. You can't really see that, but squeezing the y-axis, and you can also squeeze the x-axis. And I don't know if at this point you want to actually take a screenshot, I guess, of that. And then I usually do just a copy paste. I don't know if there's a great way of doing this. See if I can get back to my notability. And let's just paste that in here. Paste image. Fantastic. So now we can see that y-intercept value right here. And we can see, let's see the y-intercept. Can I draw that in? Oh, maybe it's not letting me draw it in on top. There we go. So there's that y-intercept value of 10.99. All right, and then we can see it as a positive slope of 1.49. Okay, so if you ordered a medium pizza from Domino's right now, what ingredients would you have for your topping? So this is going to be your individual question. I can tell you what my favorite pizza is going to be. It's going to start off with, I'll keep the purple here. It's going to start off with pepperoni. Other purple. And then we're going to put some bacon on there. And pineapple, definitely. And if we're keeping going on toppings, then I'll probably put onions on there, and I'll also put green peppers on there. I essentially like all pizzas. There's really nothing I don't like. I am not a fussy eater. I love all kinds of food. So I'd be happy with other pizzas, but let's say this is my like Swig Supreme pizza. Swagman Supreme pizza. There we go. So according to your equation, how much would you expect to pay for your pizza? Okay, well, I have 1, 2, 3, 4, 5 toppings. So now I'm going to put in my 5 toppings. And remember, our equation was 1.49x. Remember, x was the topping. So I have 5 toppings on my pizza, plus the original 10.99. And if I type that in, and feel free to use your calculator to do any of this. So you can just type in 1.49. And of course, you might get an ad pop up, which kind of stinks, times 5 plus 10.99. And I get $18.44 for that pizza. That'd be kind of an expensive Domino's pizza. More like a Pizza Luce price right there, but that's all right. If you double the number of toppings that you order, do you pay twice as much? Why or why not? Okay, so if we had 10 toppings instead of just 5 toppings, does that double our pizza price? Okay, now be thinking about that for a sec. Well, let's just put in our amount, right? We've got, let's say we double the amount of toppings, so we have 10 toppings instead of 5 toppings. So if I do that calculation, 1.49 times 10 plus 10.99, I think I end up with $25.89. Okay, so that's what our equation makes. So that's the equation. Now, if I had this for my 5 topping pizza, and I'm saying, am I asking, is that price doubled if I put 10 toppings in? Well, if I double that price, that's going to be way more than $25.89. Let's see, that'd be $36.88. All right, so no, my price would not double. The topping price doubles. Like, I paid twice as much for the toppings, but the base cheese price stays the same. In other words, I still just pay this $10.99, even when I'm doubling the toppings. I still just pay that $10.99, just like I paid up here with the 5 toppings. But what does change then is that I am going to pay twice as much for the toppings, but that doesn't make my pizza $36.88. It's just $25.89. Okay, hopefully that makes sense. All right, so what's the equation for the price of a small Domino's pizza and the equation for the price of a large Domino's pizza? Well, let's take a couple examples. If we take a couple examples, we should be able to track this down. So we've got a couple pieces of information here. Let's start with the small. So notice the small, there's only one topping here. So one topping, and it's $9.99 for that pepperoni pizza, for a small pepperoni. And then we have this one, where it has 1, 2, 3 toppings, chicken, black olives, and jalapeno peppers. That's an interesting combo. So that would be 3 toppings, and it says that it's $11.99. All right, let's go ahead and do some calculation of what that price would be. Let's go ahead and figure out the per topping price. I don't know, will it still be $1.49? Let's check it out. So if we're gonna take each one of these, remember, let's say this is x1, y1 up here, and x2, y2. And so let's subtract our y values. And then remember, I'm calculating a slope here, a rate of change. And let's subtract our x values. So that gives me 2 over 2, which is the same as $1 slope per topping. So the per topping price here is $1 per topping. And let's see, if I was doing my y-intercept, well, if I had a 1 topping pizza that was $9.99, and I want to know for 0 toppings how much it would be. So let's just take off 1 topping at $1 per topping. So if we take off that $1 topping, that leaves us with $8.99 for our cheese pizza. And this is like our y-intercept. So now our equation in y equals mx plus b would be y equals 1x plus $8.99. So that is our medium pizza. So this is our medium. Sorry, not our medium. We did the medium first. My bad. This is our small pizza price. So notice it has a little different price structure. The price per topping is $1 instead of $1.49. And it has a little different base price too, which of course would make sense if it's small. You have a smaller base price. All right, and then let's do the same thing for the large pizza. Let's see, how many toppings do we have here on the large? We got 1, 2, 3, 4 toppings on them. So that's 4 toppings, and it's $19.75 here. And then we have another large pizza that's just 1 topping, and it's $14.68. All right, so once again, let's go through and figure out, all right, what is the price per topping? In other words, what's the slope here? So x1, y1, x2, y2. All right, so let's see, we've got 1468 minus 1975. I probably should have done the reversed those, but oh well. By the way, you can reverse them as long as it doesn't really matter which one you call x1, y1 or x2, y2. You just have to stay consistent with the way you subtract. So if we're going this direction like we always have, then I guess I have to do x2 minus x1. All right, so that gives me a negative number here, negative 5.07, I think, and then negative 3. Eesh. So that's not a real wonderful sort of fraction there. But let's see, let's just take those and divide them. So 5.07, and I put a negative out in front of it, yeah. And then divided by 3, negative 3, 169. Okay, so $1.69. So that's our per topping. That's our slope, remember? But also our per topping price. And let's figure out what our y-intercept would be. So if one topping was 1468, and if we subtract off just $1.69, because that's how much one topping costs, $1.69. So if we subtract off that one topping, that leaves us with $12.99. And remember, this would be our cheese price. This is our y-intercept. Kind of running out of space here. So our equation for this, once again, would be our y equals mx plus b, so 1.69x plus $12.99. And that would be our large. So for each one of these situations, we had to kind of figure out what's our slope, what's our rate of change. In that case, it's the per topping price. And then what's our y-intercept, which is the original cheese pizza without any toppings. And so notice they all have a little bit of change or a little bit of a difference in their price structure. Each one has a little bit different slope per topping. Each one has a little bit different y-intercept. Of the three sizes, which has the greatest cost per topping? Well, the small was, let's just go. So remember, small was $1.49. Is that what the small was up here? Yeah. So small was $1.49. Nope. Take that back. The small was not $1.49. The small was the one right here. That's the small. I kept thinking that the first one we did was the small, but the first one we did was the medium. So there's our small. And then the medium was the first one that we did. So that one back up here, remember, was $1.49 per topping. And then our large was $1.69 per topping. Right there. So which had the greatest cost per topping? The large at $1.69 per topping. All right, add the equations for a medium and large pizza to your Desmos graph for the small pizza. Insert a screenshot of the graph, and so we should be able to see a difference for each one of them. All three of them are different lines, so let's go ahead and do that. Not the calculator, let's go into Desmos. There we go. All right, so we had y equals 1x plus 8.99. That was our small. All right, and then we had our large, which was y equals 1.69. Trouble typing these in. 69x plus 12.99. Okay, so that's interesting over here. Now they all kind of crisscross each other. However, it doesn't make sense. Remember, our x-axis is the number of toppings. So I'm actually going to kind of go over here. And this is really the picture of the graph that we want, right? Because we want the number of toppings to be positive. Although the graph goes on forever, the number of toppings can only be positive. So this is what the three graphs start to look like. The small would have this, would be the blue one, the medium would be the red one, and the large would be the green one. And they all have slightly different slopes, so they all have slightly different steepnesses. And so if we're looking at which one increases the most per topping, then you can see the green is the steepest. The one that doesn't increase as much per topping is the blue one, which is the small. So let's go ahead and take a screenshot of that. Let's paste that in. So we'll copy. And we'll go back to our Notability and paste that in. Let's go ahead and do that here. Awesome. All right, so we did that number 9. If you had a maximum of $20, what is the maximum number of toppings that you could choose in each size, small, medium, and large? Which one would you choose? Okay. Well, let's go ahead and start with the small. Small is green here. So our small equation was y equals 1x plus 8.99. And we're saying if you had $20 to spend, then how many toppings would you have? So we're going to put 20 in for the cost. And let's go ahead and work backwards and solve for the number of toppings. So now we're just going to solve that equation. So let's subtract 8.99 from both sides. That leaves us with 11.01 is equal to 1x. So x is equal to 11, so about 11 toppings. So this is a small. All right, and then we had the medium, which was one up here, so 1.49x plus 10.99. And if we said, all right, if you had $20, let's put in that for y, how many toppings would you be able to solve for? So let's work backwards and solve this guy. So we'll subtract 10.99 from both sides. That leaves us with 9.01 is equal to 1.49x. Okay, and then we do have to undo multiplication here by dividing. So two-step equation solving here, good practice on that. That leaves us with, let's see, 9.01 divided by 1.49. When I type that into my calculator, I get 6.05. So about 6 toppings. So that's a significant difference there between the small. Get a lot more toppings on the small. Let's see, am I gonna have room for the large here? All right, so my large, let's see, I guess that was blue. To write a little bit smaller over here. So my large was, what, 1.69x plus 12.99. Let's put in $20 and see how many toppings that gets us. So we'll solve this. Put 20 in for y. Let's solve this. Undo the addition by subtracting 12.99 from both sides. And that leaves me with 7.01 is equal to 1.69. Oops, I forgot the x up here. 1.69x. And then undo multiplication by dividing. And I get x is equal to 4.15. So about 4 toppings on the large. All right, so which one would I choose? Well, personally, I like a lot of toppings on my pizza. And if it was just me, maybe I would choose the small. But if you choose the large, then you have leftovers. And honestly, I'd be happy with 4 toppings, and I could have some leftovers there and feel like I really used my money well. So I would choose the large, since 4 toppings is pretty good, and I'd have leftovers with my $20. So that's what I would say. Okay, so this is a really good problem, you guys. If you stuck with it all the way through, or if you just paused the video and fast forwarded to the spots that you need to, that is fine as well. But hopefully you learned a little there and could see a really good application for our work